very well on your test. We are now starting chapter 12, which is graphing absolute value functions. Don't forget that your Regents Review number 2 is due tomorrow. Taking a look at the do now, we want to evaluate each expression. Something that you need to remember is that absolute value of a number is always equal to its distance from 0. So if you're looking at part A, you want to think to yourself, how far away is negative 7 from 0? Well, negative 7 is 7 away from 0. For part B, how far away is 6 from 0? 6 is 6 away from 0. And part C, how far away is 0 from 0? Well, that would be 0. Taking a look at question 1, we want to graph the absolute value of the parent function. That means there have been no transformations performed on this function. So I went to y equals on my calculator, and I typed in the absolute value of x. Now, you may not know where to find the absolute value of x. Y equals, to get y equals the absolute value of x on your calculator, I'm going to first go to y equals. Clear out anything that happened to be in there. Now I'm going to go to alpha, window, choice 1, ABS stands for absolute value. So if I wanted to graph the absolute value of x, I would type it into my calculator, and now I can go to my table and plot all of the values that fit. So when you look at your table, I just dragged it over. I'm going to plot all of those values. So negative 5. I could have even gone up to, if I wanted to, negative 6. Negative 4, negative 3, 3, negative 2, 2, negative 1, 1. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6. I'm going to draw in the rest of my graph. Perfect as I can. There is your parent function, y equals the absolute value of x. I want you to write down a little bit of information about this parent function. So you want to state the vertex, which is also known as the turning. So the vertex is right here. This is the point 0, 0. I want to state the domain. Domain means the x values that are graphed. So when you look for the domain, you have to look at the graph from left to right. So I'm going to start looking at my graph at the most left point, which is right here, and then I'm going to bring my eyes this way, all the way over to my right point. In both cases, I see an arrow on the left and a continuous graph, and then an arrow on the right. So what that means is that your domain is all real numbers. Now you can state that in words, or if you wanted, you could have written that in integral notation, which would have been negative infinity to infinity, or you could have written that in set notation, which would have been x such that x is an element of all real numbers. For part D, you want to state the range. To find the range, you're looking from bottom to top. So when I'm looking at my graph, I'm looking from the lowest y all the way up to my highest y. So my lowest y on my graph is 0. And then when I look up to the top, I see arrows as well. So the lowest y that I could have here would be 0, and the highest would be infinity. So you could write that as an inequality, y is greater than or equal to 0. You could write that in interval notation, bracket 0, comma, infinity. Or you could write that using set notation, y such that y is greater than or equal to 0. Now let's talk about transformation of parent functions. You already know the rules to transform absolute value functions because we talked about the transformations of quadratics, and the rules are the same. So just to refresh your memory, if you take a look at this first picture here, when you're graphing a quadratic function, y equals x squared, your parent function, and then you have have the function y equals x squared plus 4, that means there was a vertical shift up 4. If you were to graph y equals x squared minus 4, that means it's a vertical shift down 4. So if there's a number being added or subtracted to your parent function, that means it's a vertical shift up or a vertical shift down, depending on whether it's positive or negative. Positive means up, negative means down. If you're taking a look at your parent function y equals x squared and comparing it to y equals negative x squared, in the second diagram you should see that that negative a value tells you that your graph was reflected over the x-axis. Taking a look at the third part, the coefficient of x squared, or the a value, tells you how wide or narrow your graph is compared to your parent function. So if your a value, as in the diagram right here, is a number between 0 and 1, your graph is going to get wider than the parent function. And if your a value is a number that's greater than 1, your graph is going to get narrower than the parent function. So here are some examples using those same rules having to do with absolute value. So take a minute to look at the examples. Now we're going to ask you to label each graph with this equation. So your choices are f of x equals the absolute value of x, g of x equals 3 times the absolute value of x, and h of x equals 1/3 times the absolute value of h of x. So take a minute to look at your graphs and to label them on your paper with what you think would be appropriate. Okay, so I'm going to start with trying to label f of x. So f of x is the absolute value of x. So one way I could do that is type that equation into my calculator, look at the table of values, and look at the points that are plotted. Another way I could do this, I can think about the slope of this function. So the coefficient of the absolute value of x is 1. So what that means is on the right side of my graph, my slope should be a 1, and the left, it should be a negative 1. So if I looked at this graph right here that I'm highlighting in blue, little hard to trace over it exactly on the smartboard, but you should see that the slope is up 1 right, where to look. Here, and on the left side it's up 1 left, up 1 left, up 1 left. So this is my function f of x. The next function I'm going to look for is g of x. Now g of x has a coefficient of 3. So that means that my graph should be narrower than my parent function. And in fact, it should have a slope of 3 on one side and negative 3 on the other. So the correct graph here would be this one that I'm highlighting in green, which is g of x. And again, if I want to check the slope, I can say, okay, up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. The last one, it must be this one, which is h of x. Notice my coefficient's 1/3, so compared to my parent function, it should be wider. If I wanted to check the slope, I could, just to make sure that's correct. So up 1 over 3, up 1 over 3, up 1 left 3, up 1 left 3. Lastly, let's take a look at exercise 3. You're asked to graph the function f of x equals the absolute value of x minus 5 plus 3. So I'm going to go to y equals on my calculator. I'm going to type in y equals, to get the absolute value again, you're going to go to alpha window, choice 1, absolute value of x minus 5. Now you have to take out to write down the plus 3. And now I'm going to plot all my points. 0, 8, 1, 7, 2, 6, 3, 5, 4, 4, 5, 3, 6, 4, 7, 5, 8, 6, 9, 7, then 10, 8. If I wanted to on the left side, I could really even plot more. You don't have to plot Patrick. You can do a better job at connecting these. That doesn't look so good. Let me choose the line. Okay. As you know, it has to be perfect. Okay, so my graph is graphed. Now I want to know the domain over which the function is increasing. So I'm going to think about drawing the graph. So if I were to draw the graph, I'm just going to trace over here and say, okay, start at the top left. My pencil is going down here, so this would be decreasing. And then my pencil is going up here, so this would be increasing. Now I have to express my answer. First, the question asks, where is my function increased? So I'm focused on the right-hand side of my graph. So I want to look at where the vertex is. The vertex is 1, 2, 3, 4, 5, 3. So when you're writing your answer in terms of whether a function is increasing or decreasing, you're always writing it in terms of the x value. So you can see at an x value of 5 here is where the vertex is. But anything to the right of an x value of 5 is where it's increasing. So let's say x is greater than 5, or if you wanted to write that in integral notation, you'd be parenthesis 5, comma, infinity, parenthesis. Or in set notation, x such that x is greater than 5. Part C asks where is it decreasing. So if I again go back to my vertex x value, which is a 5, I can see it's decreasing to the left of 5. So that would be x is less than 5, or parenthesis negative infinity, comma 5, parenthesis, in interval notation. And in set notation, x such that x is less than 5. So you can choose whichever notation you prefer. Remember, when you're asked a question about increasing or decreasing, you're never including the vertex x value, because at that point you're not going up or going down. Okay. Now it's your turn. So you should see 8 questions attached to your notes packet. What you're going to be asked to do is pick the appropriate choice for each, and Mrs. Carnes and I will go over the answers tomorrow.
Okay, so what Mrs. Harsh and I expect from you tomorrow is that you've watched the video, that you've taken notes as you've watched the video. So if any part seemed a little confusing, you want to go back and rewind and rewatch it, make sure that you've taken notes appropriately on each question, and that you've completed these 8 questions. And the Regents Review is also your homework, the Regents Review that you got yesterday when you finished your Part 1s. So we expect to see this packet of notes completed, as well as your Regents Review completed. And don't forget that the circled questions means that we expect to see work. Okay, thank you so much for watching. Yeah.